Hello everyone. In today's video, let's understand the chemical properties of acids and bases. Precisely, the chemical reactions of acids and bases with different substances like metals or metal carbonate. So, without wasting much time, let's get started. Now, the first reaction that we are going to discuss is how metals react with acids. Now, as you can see in the slide, when metal reacts with acid, it will form salt and release hydrogen gas. So this is the general reaction, and I would recommend you remember the general reaction, because once you know the general reaction, you will be able to guess which particular salt might be formed in the reaction. So again, metal plus acid gives you salt and hydrogen gas. Let's take an example. Suppose we take zinc metal or zinc granules, and let's say we add it to something like dilute hydrochloric acid. Then, now when I say acid here, obviously you can use any acid. You can use hydrochloric acid, or you can use sulfuric acid, or any other acid for that matter. So in this particular example, I'm taking reaction between zinc and hydrochloric acid. So if I put these granules in the hydrochloric acid, then they are going to react. Now, how do I know they are going to react? Is there are some signs that you can obviously see here. You will see some bubbles forming in the test tube or in the beaker. If you touch the beaker from outside, it will be slightly warm, as this reaction is slightly exothermic as well. So these bubbles are basically of the hydrogen gas. So as the reaction occurs, we will get a salt by name zinc chloride, and we will also be able to get hydrogen gas. So if I want to write the equation of the reaction that we just discussed between metal and acid, we can say zinc metal reacts with acid like HCl to give you zinc chloride plus hydrogen gas. Or if you want to take sulfuric acid, then we can say zinc metal reacts with sulfuric acid it gives me zinc sulfate plus hydrogen gas. So both these equations are very similar. This is a simple displacement reaction wherein zinc, being more reactive than hydrogen in the acid, it is going to displace hydrogen and form salt and hydrogen gas. So in this reaction of acids and metals, how do I know that the gas being released is hydrogen? Because hydrogen is a colorless and odorless gas. So there should be a way to check whether the gas is hydrogen or not. So we can perform a simple test. When hydrogen is released, we can pass it through the soap solution, as you can see in the animation here. And when it is passed through the soap solution, it will form soap bubbles. When you get a candle next to these soap bubbles, these bubbles will explode. This is because hydrogen is a highly inflammable gas. So these tiny explosions that you'll hear, the pop sound that you'll hear, will confirm that the gas released during this particular reaction is hydrogen. The second reaction that we are going to see is when a base reacts with any particular metal. So the reaction of base with the metal is very similar to the reaction of acid with metal. So as you can see in the slide here, a metal reacts with a base to form salt, just like the acids, and also release hydrogen gas, again same like the acid. So the reaction is very similar or very same like the acid and metal reaction. Now we can take an example here. So if we add zinc to something like sodium hydroxide, which is a strong base as we know, then it will form a salt by name sodium zincate, and it will release hydrogen gas. So if I want to write the equation for the reaction that we just discussed, we can write it as zinc metal reacts with base like sodium hydroxide to form sodium zincate. The formula is Na2ZnO2 plus hydrogen gas. So this is the reaction, or this is the equation for the reaction between base and a metal. And as you can see, the reaction is actually very similar to reaction between acid and metal. The next reaction is reaction of acid with metal carbonate, or we can also see the reaction between acid and metal bicarbonate, which are also called as metal hydrogen carbonate. So what exactly is metal carbonate? So metal carbonate will basically have metal and carbonate ions. So something like sodium carbonate, which is Na2CO3, can be considered as metal carbonate. What is metal bicarbonate or metal hydrogen carbonate? It will simply have metal and hydrogen carbonate ion. So something like metal hydrogen carbonate, so sodium hydrogen carbonate, can be called as a metal bicarbonate. Now both these metal carbonates and metal bicarbonates actually react in a very similar manner to acids. So whenever acid reacts with any of these substances like metal carbonate or metal bicarbonate, you get three products. The first product is a salt, the second product is a gas, that is carbon dioxide, and the third product is water. Say for example, if I take dilute hydrochloric acid and react it with something like calcium carbonate, I'll get a salt, that is calcium chloride, plus carbon dioxide gas will be released, and the third product will be obviously water. Now if you want to write the equation for the reaction that we have just discussed, we can say a metal carbonate like sodium carbonate reacts with acid like HCl. It will form a salt, that is sodium chloride in this case, plus water plus carbon dioxide. Or if I react sodium bicarbonate or sodium hydrogen carbonate with acid like HCl again, I'm going to get the same result. I'm going to get sodium chloride plus water plus carbon dioxide gas. Now how do you detect the presence of carbon dioxide in this reaction? Again, carbon dioxide is also colorless and odorless gas. So to detect the presence of carbon dioxide, we perform something called as a lime water test. Lime water is basically slaked lime or solution of calcium hydroxide. So we take a freshly prepared calcium hydroxide and pass carbon dioxide gas through this. Now remember, freshly prepared carbon dioxide is colorless. When you pass carbon dioxide through this particular solution, it will turn milky white due to the formation of a precipitate of calcium carbonate. This formation of precipitate confirms that the gas released is carbon dioxide. Now, you have to be careful with this particular lime water test, because if you pass excess carbon dioxide, that milky white color might disappear. So here is why it happens. When you pass excess carbon dioxide through the solution, it forms calcium bicarbonate or calcium hydrogen carbonate, which is a water-soluble substance. So the color of this solution goes from milky white to colorless. The next reaction is called the neutralization reaction. Neutralization reaction is a reaction between acid and a base to form salt and water. So when acid and base react with each other, they are chemically opposite to each other. So when they react, they will try to cancel each other out. The acid will try to cancel the basicity of the base, and the base will try to cancel the acidity of the acid. So basically they try to neutralize each other, and hence we can call this reaction as neutralization reaction. So we can take an example. Let's say an acid like HCl or hydrochloric acid reacts with a base like sodium hydroxide. It forms salt and water. This reaction is called neutralization reaction. Now we should understand here why this neutralization might happen. We have seen in the previous videos that the acidity of the acids is because of the hydrogen ions, whereas the basicity of the base is because of the hydroxide ions. And in this reaction, these two ions combine with each other, that is H plus ion and OH negative or hydroxide ion combine with each other and they form water. So this basically is the reason why the acidity and the basicity of the base might get cancelled, because the ions which give them these properties are forming water by combining with each other. Now let's understand neutralization reaction with this simple animation. So I've shown in this animation that there is acid in this burette, the tube that you see, whereas in the conical flask below there is a base mixed with phenolphthalein. As you must have known from the previous video that if you mix phenolphthalein in base, it gives pink color. As I go on adding acid drop by drop, the color of this solution will change from pink to colorless as the base will be neutralized by the acid. So this kind of reaction where acid and base react to form salt and water is called neutralization reaction. The next reaction is reaction of metallic oxides with acid. Now metal oxides react with acids to form salt and water. And if you recall the previous reaction that we have seen, which is the neutralization reaction, this particular reaction is very similar to neutralization reaction. So we have an acid here, we get a salt and we get a water, which is same as neutralization reaction, which means metal oxide should be a base. So remember, metallic oxides have basic nature, or they are basic in nature because they can react with acid to form salt and water, which is very similar to neutralization reaction, and hence we can say metal oxides are basic in nature. So if we want to take an example of reaction between metallic oxide and acid, we can say copper oxide, which is a metal oxide, reacts with hydrochloric acid. It will give you copper chloride, which is a salt, plus water. So since this reaction is similar to neutralization reaction, we say that copper oxide or other metallic oxides are basic in nature. So in this example that we have just discussed, if we take black copper oxide and add it to dilute hydrochloric acid, which will be colorless, the solution will turn blue due to the formation of copper chloride. So color change to blue color tells us that copper chloride has formed, and in this reaction no gas will be evolved. Now the last reaction that we need to see is reaction of non-metallic oxide to the base. So if we take a non-metallic oxide like carbon dioxide and react it with a base like sodium hydroxide or say calcium hydroxide, it is going to form a salt and release water. Now this is also very similar to neutralization reaction. For example, we have got a base here, we get salt, we get water, which is all same as neutralization reaction. So that means this non-metallic oxide must be acidic in nature. So let's take an example of this type of reaction. Suppose I take calcium hydroxide and react it with carbon dioxide, which is a non-metallic oxide. This is going to form salt, which will be calcium carbonate in this case, and water. Now, since calcium hydroxide is a base and we are getting salt and water, which is similar to neutralization reaction, we can safely say that non-metallic oxides are acidic in nature. So non-metallic oxides are acidic in nature as they react with base to form salt and water, which is similar to neutralization reaction. So this is what you need to know about the chemical properties of acids and bases. In the next video, we'll try to understand about salts, how they are made and their uses. See you in the next one. Till then, keep learning.